The problem here is that all this webbing here puts this flange farther back, and this is to strengthen up this transmission. That's why the drive shaft on the right hand side is too long. So a special adapter's got to be built. What you're looking at here are shaft adapters on the right hand side. Now this was a stock X19 shaft adapter that I put in, forget about this brass sleeve here, that I put into the right hand side of the Abarth transmission. Unfortunately it leaks and it does engage the splines, so a brass sleeve had to be made and pressed on, and I did that and put it back in. On the downside of this, if you can take a look here, hopefully you can see how mashed those teeth are. On the right side, the Abarth does not have a groove cut in it for the spring clip. What it does have is between the splines of the differential and the bearing, there's like a recess. So once I figured that out, this failed 2 days before freakout. And what I did is I took another shaft adapter, put another brass sleeve on it for sealing, for the oil seal, and I relocated this groove so it would stay in it. I put about 150 miles on this one, and it was bearing on approximately this ½ inch that was left. But what we really need, if you want to utilize the full engagement of the spline, is this one here. Now this one is a cut down shaft from the Abarth, and what they've done on that transmission is they made sure that the half shafts between the constant velocity joints are both the same length, so we don't have torque steer. Now in the X19 that's not an issue. Unfortunately though, they didn't have a groove cut in it, so that has to be ground in. Now we're going to just flip this over. I haven't done the welding and the pinning yet. That shaft is off the stock Abarth, cut to length, and you can see how I've cut it with a grinder and then cut it with a saw. The outer 1/8 of an inch is case hardened. It's very hard, and the only way you're going to cut it with anything other than a torch is with a grinder to get through that 1/8 of an inch. Now if you turn it on the lathe when you're doing it, you can go around and then you can put it in the saw after, and that was just cut with a regular bimetal saw blade. And you can see here how it's kind of skipped, and here where it's cut. What I'm going to do now with this is an all stainless steel. This was a stainless steel puck that was about 2 inches by 4, and I've machined it to resemble this one here. And what I'm going to do now is I'm going to take a carbide bit and I'm going to bore 2 holes, one on each side, and put 2 hardened steel pins in there, and then TIG weld this all the way around. And what that will do is, this is a press fit. It's an interference fit. I had to use a 15-ton press to get it to go in there and seat. And the pins will stop it from turning, and the press fit keeps it true, and the TIG weld is just going to stop the whole thing from ever coming apart, which probably you don't need, but it's more just like a, you know, like a locking clip is the TIG weld. Stainless steel has an affinity to absorb carbon, so when you're welding a high carbon steel so it doesn't get brittle, the stainless steel will absorb the carbon, and we should still have a sound weld. What you're looking at is my computer screen. Right now I'm just doing these bores for the locking pins that are going to go inside this hub. So here's the setup, and hopefully this camera can show the relief here, but that hole is 600,000ths of an inch deep, and you can see it's on the parting line. You can just clean a little bit of that off between the new hub adapter and the Fiat Abarth right half shaft. So the pin will go in, and then after a TIG weld along this seam and onto these pins with the stainless, and that will stop it from slipping at all. This is just a shot showing you the holes, how they've been bored through the hardened portion, through the stainless steel. Once those pins are in there, should the shaft want to try to spin while it can't, it would have to shear the hardened steel pin, so that's not going to happen. Plus it's a press fit. We should be in pretty good shape here. Well, okay, that was the final step. Here we have the TIG welding was done, and you can see how I've waved the weld over towards the side and picked up the pin. And those hardened pins, I think are 85 Rockwell on the C scale, so they won't shear, and the stainless will flow in there and absorb the carbon from the pins and keep them in place. So that's the adapter done. Next step, pack it with some grease and install it on the car.